So hello everyone, welcome to day 5 of this series. So today we're gonna do 2 questions and I'll wrap it up quick because I don't have electricity again. My battery is low, so yeah. Okay, and my voice might be a little low because I'm kind of whispering right now. It is late. It is like late, and the environment is quiet. So yeah. So see number 8. State one difference between a scalar quantity and a vector quantity and give one example of each. Okay, so a scalar quantity is a quantity that only has magnitude. A vector quantity has both direction and magnitude at the same time. So imagine a displacement. Displacement has a vector quality. It shows the magnitude, which is how far it is, and it shows the direction. So maybe it's like north, something east, or something like that. So yeah, and example of a scalar quantity would be distance. Distance only shows the magnitude and how far you go. It doesn't show you the space. It doesn't show you the direction. Okay. So yes. So let's go with B. A plane has an airspeed of 500 km per hour due north. A wind blows at 100 km per hour from east to west. Okay. Draw a vector diagram to calculate the resultant velocity of the plane. Give the direction of travel of plane with respect to north. Okay. So draw a vector diagram. So the plane has an airspeed of 500 km per hour due north. Okay. So let's draw that, and then it has an arrow, and then the wind blows at 100 km per hour from east to west. So it's going like this, right? East to west. Okay. So let's draw another vector line if we like this. Okay. So the total vector will be this. The resultant vector will be this. Right, okay, I'll draw with this. So the resultant vector will be that. Okay. So let's name it A, B, C. Okay. So and then I drew the vector diagram. Now calculate the resultant velocity of the plane. Give direction of the travel of the plane respect to north. Okay. So let's see here. So this is 500 km per hour. This is 100 km per hour. Okay. So I just need to calculate AC, which is the resultant velocity. So I just need to use the Pythagoras theorem. So AC vector will be 500 squared plus 100 squared, and then if I put that into a calculator, we will get 100 squared about 509 or 510, but yeah, about 509.9 kilometer per hour. Okay. So now you can calculate the direction. Okay, the direction will be this. And let me do this. North, east, south, west. Okay. So I need to calculate theta right here. So I'm gonna use tangent. So tangent theta equals to opposite length divided by the adjacent length. So now then theta will be tangent inverse 1/5. So theta will be, if I put that into a calculator, 1/5, you get 11.3 degrees. So Also, the bearing, it will be north 11.3 degrees west, and it's moving at 509.9 kilometers per hour. It should be right. And the plane flies for 15 minutes. Calculate the displacement of the plane in the time. Okay. So wait, let me wait a second. Put these. Okay, number C. So we just need to use the normal distance equals speed over time. Distance equals speed times time. I'm sorry. So this will be displacement. Displacement will be equal to speed, which is 509. Let's actually round it up to like 5010 or something, yeah. Multiply by and then time, which is 15 minutes, like turn it into. Oh wait, this is 510 is kilometer per hour. So maybe turn this into hour. So to turn this into hour, divided by 60. So this will get me, sorry a second, 510 multiplied by 15 over 60, 127.5 kilometers, roughly speaking. There we look at that. Okay, so yeah. Yeah, that's it. Number 8 is done. So the answers are, this is a vector diagram, this is the answer, and this is the answer. Okay, so let's move on to the next question. Okay guys, so this is the next question. Number 9. A small aircraft for one person is used on a short horizontal flight. On its journey from A to B, the resultant velocity of the aircraft is 15 meters per second in a direction of 60 degrees east of north, and the wind velocity is 7.5 meters per second due north. Okay, like this, right? Okay, wait, sorry. Like this, okay? So, and then number A, show that the aircraft that travels from A to B, A should be pointed to east. Oh, okay. This is the way to do it. So that's it. Okay, so to figure out this question, so let's actually. So the aircraft resultant velocity of the aircraft is this, which is about north 60 degrees east, right? So this question is asking the aircraft should be pointed to east. So I think we have to calculate the wind speed of the aircraft, the wind of the aircraft, the velocity. So let's read the question again. The wind velocity is this much, and the resultant velocity is here in the direction of 60 degrees. So let's actually draw a vector diagram of that. Okay, so wind velocity is due north. So the wind is actually this way. The wind is actually this way. And the velocity of the aircraft, that's the resultant velocity of the aircraft. The resultant velocity is like this. Okay? The resultant velocity of the aircraft is this. So I will know the velocity of the aircraft, and this is the velocity of the aircraft. This is why it should be pointed to east, because the whole graphic, the whole bearing is like this, like north, east, south, west, right? So this is like 7.5. I'm not gonna add units. Yeah, 5. This is the velocity of the aircraft, and this is the resultant velocity of the aircraft. So to get the resultant velocity here, the plane needs to point east, north. The plane needs to point east if the wind speed is 7.5 meters per second. Okay, so this should be this question. So number B, let's see. After flying 5 kilometers from A to B, the aircraft returns along the same path from B to A with a resultant velocity of 13.5 meters per second. Assuming that the time spent at B is negligible, calculate the average speed of the complete journey from A to B and back to A. Okay, so let's see here. So the aircraft go from A to B and then back again. So it's like this, right? And then after flying for 5 kilometers, and then B to A with a resultant velocity. So the resultant velocities are different. The from A to B it is 15 meters per second, while B to A is 13.5 meters per second. The distance is 5 kilometers. Okay, so I just need to find the average speed of the whole thing. So to calculate average speed, GE average speed, you need speed equals total distance, sorry for bad handwriting, guys. I'm writing with a finger and divided by total time. So we have the total distance. Total distance is 10 kilometers. Total time we have to find, right? And we can find that very easily. So for here, the total time would be time equals to distance over speed. Then let's see, so 5 over 15, which is 1 over 3. Oh wait, this is meter per second. Okay, wait, I can't do that because the units are different. The units are different. So I have to turn 5 kilometers to 5 meters actually. So that is 5,000. So T would be 5,000 meters divided by 15 meters per second. And that will be about, I'll write it in fraction, 1,000 over 3 seconds. And then here it is, T will be 5,000 over 13.5 meters per second, and this will get, okay, that's a lot. Okay, wait. About 10,000. That looks like 1 over 27. So now I just need to find the average speed, which is total time, and if you add these both up, then you get the average speed. Total distance is about 10,000 meters, and the time will be 1,000 over 3 plus 10,000 over 27. And then if I put that into the calculator, well, we will get, wait a second, guys. Okay, 1,000 over 3 plus 10,000 over 27, about 14.21 meters per second. So this will be the average speed of the whole journey. So yeah, so this is number 9, that is number 8. So yeah, thank you for watching, everyone. So I'll wrap this up today. So chapter 1 for A-level physics is finished. So tomorrow I'll do some rotational velocity question, and the day after tomorrow we can do chapter 2 of A-level physics. So yes, I'm really excited for that. So thank you guys for watching, everyone. Goodbye.